Hi, it's Mrs. Young, and I am here to talk to you today about how to use sine and cosine functions to model real-world phenomena, real-life applications here. So go ahead and grab your yellow booklet that looks just like this from your interactive notebook on page 49, as well as your graphing calculator. You might want to press pause while you grab those, and then when you come back, we'll be ready to go. Awesome. Now that you have everything you need, let's go ahead and take a look. In this video, we're only going to look at the first example, which is on Ferris wheels. We can look at the others in class. And so Ferris wheels are a great real-world phenomena that models sinusoidal motion. And that's because the Ferris wheel is a circle, and as a rider on the Ferris wheel, you are going up and down, up and down, up and down, which is exactly what the sine or cosine curve does. And so in this example, we're told that the Ferris wheel has a diameter of 30 meters. We're going to use that info. And that the center of the Ferris wheel is 18 meters above the ground. We'll need to know that as well. And then it makes one complete rotation every 60 seconds. In part A, we're asked to draw the graph of one complete cycle. It's not asking us to draw the circle. It's asking us to draw the motion of the rider. But in order to understand that motion, let's go ahead and draw the circle and just get some information in our heads before we draw the actual graph for the motion of the rider. So let's just take a circle, which would represent the Ferris wheel. We're told that this Ferris wheel has a diameter of 30. I'm going to draw that in here vertically. There is a reason behind that, which you'll see very shortly. And we're also told that the center of the Ferris wheel is 18 meters above the ground. So from here to the ground is 18 meters. Now, the Ferris wheel itself doesn't sit on the ground. The wheel does not sit on the ground. It usually sits on some base. And so as we're taking a look, we know that this center is 18 meters above the ground, but we also need to pay attention to something else, which is the radius of the Ferris wheel itself. If the diameter is 30, what's the radius? You got it. The radius is 15. Now, if I go from the middle to the minimum, and that distance is 15 as a radius, and I go from the middle to the maximum, the top of the Ferris wheel, and that distance is 15, then in my rider motion, I'm describing what? I hope you're thinking amplitude. Amplitude goes from middle to minimum as well as middle to maximum, which says that the minimum here at the bottom of the Ferris wheel is 3 meters, not 0 because the wheel isn't on the ground. And the maximum at the top of the Ferris wheel here is 33 meters. So that's 18, this height, plus 15 for 33, and 18 minus 15 to get this height of 3 meters. Now we're going to use the idea that we make one complete rotation every 60 seconds to draw this graph. So for part A, first I'm going to set up my scale. The horizontal axis is going to be our time in seconds. The vertical axis is going to be our height in meters. I'm going to scale the horizontal axis by 10s to 60. So 10, 20, 30, 40, 50. Need a little more room here for 60. And I'm going to scale the vertical axis to 40 or to 36 really, by 6s. So it's going to be 6, 12, 18, 24, 30, had to squeeze that one in there, and 36. So now I'm going to start to put in some information on the curve just based on some things that we saw. For example, the fact that the midline is 18 meters above the ground. So that's the line y equals 18. That's our midline. The fact that the maximum was 3 meters above the ground. So that's halfway between the 3 and the 6. So the line y equals 3 represents our minimum line. I'm sorry, I think I just said maximum. That's our minimum line. Our maximum is 15 meters above the midline, which is at 33. So the equation y equals 33 would represent the maximum. Now as we start to pay attention to the motion that this curve would make, the motion that the rider would make in order to create our curve. As a rider, we get on at the bottom. They tell us that the rider starts at the lowest point. So the lowest point on this Ferris wheel, the bottom of the Ferris wheel, is at 3 meters. That's at time t equals 0. At 60 seconds later, We're at the end of a rotation, which means we're back at the bottom, so that's also 3 meters. Now, based on what we've done in class with sinusoidal motion, we understand that if I start at the bottom and then I reach the bottom again, then halfway between those two minimums, I have a maximum. So at 30 seconds, I should be at my maximum of y equals 33. And then halfway between a minimum and a maximum, I should be in the middle. So halfway between 0 seconds and 30 seconds, which is 15 seconds, I should be in the middle. And then halfway between a max and a min again, I should be in the middle. So halfway between 30 seconds and 60 seconds, which is 45 seconds, I should be in the middle. And so this represents the motion of the rider. So this is a reflected or inverted cosine curve. This time we can stop at the dots because we're not trying to show anything past 0 or 60. So that's part A. Now in part B, we're asked to find a cosine equation for this curve. And we're going to use some information we've already said. For example, we know that the amplitude is 15. The distance from midline to maximum or midline to minimum is 15. In order to find B is the frequency, and what we know is the period. We know that it takes 60 seconds to complete a cycle. And we know that B is 2 pi over the period, which in this case is 2 pi over 60. And if we simplify that, we get pi over 30. C represents a phase shift, but in this case, we don't have a phase shift. And that's because the cosine curve has started at 0 in the x direction, which is typically where it starts. And then D represents the distance from the midline to the bottom, and in this case that's 18. So this Ferris wheel is 18 meters off the ground. So to recap, our A was 15, our amplitude, we got that from the radius. Our B, which is frequency, we complete pi over 30 parts of a curve. Remember, pi is a number, so that's about 1/10 of the curve in 60 seconds. C is 0 because there's no phase shift. And D is 18 because that is the distance of the center from the ground. That is the middle of our Ferris wheel, 18 meters off the ground. So now we will fill in the parts for the equation. Y equals A, which is 15, times the cosine of pi over 30 t plus 18. Now, there's one thing we're missing. If you take a look, remember earlier I said that this was a reflected cosine curve. Cosine usually begins at the maximum, but this cosine has begun at the minimum. So we need to make sure we represent that by making the 15 negative. So negative 15 for the reflection. So this is our completed cosine equation. Okay, 2 more parts to go. Part C asks for the height of the rider at 52 seconds. So in other words, in C, we want to know h of 52. And in part B, I really should write this as h of t to represent real world. So h of t, the height at t seconds. So then when I write h of 52, I'm saying the height at 52 seconds. So technically, we're just going to plug in 52 wherever we see t. So h of 52 is negative 15 cosine pi over 30 times 52, close the parentheses, plus 18. And we're going to use our calculator to find this out. So go ahead and grab your graphing calculator. The first thing I want you to do is to make sure that you're in radian mode. And the way that you do that is by hitting mode on your calculator and then looking down to that third row where it says radian and then degree, and hit enter on radian. Make sure it's highlighted in black and you're in radian mode. Then hit second in mode to quit to get back to your home screen, and just key in the information just like we saw it. Negative 15 cosine. Pi is second to the up arrow here, which is called a caret, second caret, divided by 30, times 52. Close those parentheses, that's a big deal, plus 18. And we find that we are 7.96 meters above the ground 52 seconds into the ride. Now there's another way to find this, and that's by graphing this curve. So hit y equals, key in again, negative 15 cosine, second caret for pi, divided by 30. This time instead of 52, we're going to put the variable x, since we want to graph for several different values, x, close the parentheses, plus 18. Now, before you hit graph, we need to set the window. So hit your window button, and set up your window as I have it here. On the x-axis, we're going from 0 to 60, and we're scaling by tens. On the y-axis, we went from 0 to 36, and we scaled by sixes. Once you have your window set up as it appears here on the screen, hit graph, and you should be able to see the same curve that we drew in part A. Now what we're going to do is insert the value of 52 while the calculator is in graphing mode, and it will give us back the corresponding height. To do that, hit second and trace. Brings us to the calculate menu. Number 1 is value, choose it. And it's waiting for us to enter in x value. The x value we want is 52. And so we see again that we have a height of 7.96 meters. So h of 52 is 7.96 meters. Now part D asks us for certain times where the height is 20 meters. At what times is the height 20 meters? We're going to go to our calculator again for this. Go back to y equals. And this time what we're going to do, in addition to plotting that cosine curve, we're going to graph the line y equals 20 to represent 20 meters. And then we'll look for the intersection between these two curves. So I've pressed graph, and we can see that we'll have an intersection point here and here. So we're just going to ask the calculator to help us find those. So hit second and trace once more. This time choose number 5, which is intersect. And I'm going to try to get as close as I can to that left intersection point. I'm just pressing over on the arrow. Press enter for first curve, enter for second curve, enter for guess, and then it will give us a time. So it's given us 16.3 seconds. Then I want to do it again for the other side, so I'm going to hit second and trace, 5 for intersect. This time I'm going to use the right arrow and make my way over to the other side of that curve. And once I get there, I'm going to press enter for the first first curve, enter for the second curve, enter for guess, and it tells me it's about 43.7 seconds. And so there are 2 times along one cycle where we're at 20 meters off the ground, and that's at about 16.3 seconds, and again at about 43.7 seconds. So review this video as often as you need. We will definitely do some more examples in class tomorrow, and post any questions that you might have to Edmodo. I hope you have a great night, and I'll see you tomorrow.